Reaction in organic chemistry, we have number one, we have what we call addition reaction, 4 basic reaction in organic chemistry. Number two, you have what we call substitution reaction. Substitution reaction. Then you have number three, you have what we call polymerization reaction. Then number four, you have what we call condensation reaction. These are the 4 basic reaction. 4 basic reaction in organic chemistry. Now, why do we say that it is the basic reaction? Why we call it basic reaction is because you cannot do any organic chemistry without any of the reaction here. You cannot combine any organic chemistry without any of the reaction here. It is either organic chemistry undergoes what we call addition reaction, or it undergoes substitution reaction, or it undergoes condensation reaction, or it undergoes polymerization reaction. These are the why we call it 4 basic. When you go to 18 and its compound, when you go to methane, when you go to ethyl, when you go to alkyl, when you go to alkanol, alkanoic, alkano, alkanoate, alkanon, alkana, amine, ester, all of them, they undergo any of the reactions. Don't worry, we will approach to the place that I mentioned for you now. Now, these are the 4 basic reactions. So when you talk about addition reaction simply means the process whereby you add either hydrogen or any of the non-metal to the compound. That is addition reaction. When you add any of them to the compound. Then substitution reaction, when there is a change. For example of this addition reaction, if I have something like, if I have methane, okay, let me just say I have 18 C2H4. C2H4 is an 18 plus hydrogen gas or hydrogen molecule. You will find out that this is going to give me how many 4 is here? Sorry, how many hydrogen is here? 4. Now when you add these two, it's going to become C2H6. This becomes what we call addition reaction. But when you come to this substitution reaction, you have something like CH4 plus chlorine molecule, and this is going to give me, I will take 1. 4 hydrogen is here, 2 chlorine is here. You have to substitute, you have to minus. Therefore, I'm going to have CH3. 1 hydrogen is out, then put it here, CH3. Then I have to substitute another chlorine here, put it here. I'm left with 1 chlorine and 1 hydrogen. Just go here, form that what we call hydrochloric acid. Substitution reaction. But when you go to what we call polymerization reaction simply means when I have a compound CH2, C2H6, all in bracket by multiplication. 2 times 2, 4, 2 times 6 will give me 12. There is a polymer, the process whereby monomers join together to form polymers. Simple one, join together to form. Then when you go to what we call condensation reaction, is addition of either oxygen, this one varies, addition of either oxygen, tetraoxosulfate 6, or any of the compound, condensation reaction. That is how this one takes place. Now, from there, let's quickly enter into what we call 3 terminologies. 3 terminologies in organic chemistry. 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 So we also, after the 4 basic reactions in organic chemistry, we also have what we call 3 terminologies in organic chemistry. The main terminologies. And these terminologies include, number 1, what we call homologous series. Homologous series. We have number 2, what we call functional group. Functional group. Then we have number 3, what we call alkyl group. Alkyl group. These are the 3 terminologies in organic chemistry. So now the 3 terminology in organic chemistry, number 1 is homologous series, functional group, and alkyl group. I am going to clean them now and begin to pick them one after the other for explanation. And you will see why we say that they are the 3 terminologies in organic chemistry. First of all, I want you to understand that from this organic chemistry, the combination of carbon and the hydrogen, which give me hydrocarbon. And when you talk about hydrocarbon is a compound that contains hydrogen and carbon atom only. Hydrocarbon is a compound that contains hydrogen and carbon atom only. Hydrocarbon, H and C, that contain hydrogen and carbon atom only. That's the meaning of hydrocarbon. And this hydrocarbon divided into 2. In this hydrocarbon, we have what we call aliphatic hydrocarbon. Aliphatic hydrocarbon. We have what we call aromatic hydrocarbon. This aliphatic hydrocarbon divided into 2 again, you have what we call saturated. You have what we call unsaturated. Then saturated divided into 2 again, you have what we call cyclic. You have what we call acyclic. Then aromatic, when you come to this saturated under aliphatic, you have example of saturated. Example of them is what we call alkane. Example of unsaturated is what we call alkene. And another one they call alkyne. These are the example of unsaturated. When you go to this one, cyclic, example of cyclic, you have what we call cyclopentane. Acyclic means straight chain, the normal ones. Then when you go to the aromatic, you are going to have number 1, benzene. You're also going to see what we call phenol. You're also going to see what we call aniline. You also will see what we call xylene. Under this place, we still have what we call methylbenzene. These are the example of aromatic, and these are the example of saturated and unsaturated. You see it. So remember, organic chemistry. Organic chemistry said it is the chemistry of carbon compound except triazocarbonate. So every other compound that you're seeing here, and because of that, it is that compound that form when carbon move with hydrogen to form what we call hydrocarbon. That is exactly what result to this place. Hydrocarbon, the compound of carbon. So the compound of the carbon form what we call hydrocarbon, and hydrocarbon divided into like this: aliphatic and aromatic, saturated and unsaturated. cyclic and acyclic. Under aromatic, you have benzene, you have phenol, you have toluene, you have aniline, you have xylene, you have methylbenzene, you also have naphthalene. But I didn't put all those ones on. When you reach down the level or the particular place, then we include it. So now with this, let's quickly go with what we call the three terminologies. The three terminologies which we have. And the three terminologies which we have there, I have made mention, we have the homologous series. And what is this homologous series? Homologous series is a family. Is a family in an organic compound. Is a family in an organic compound in which follow a regular structural pattern. Homologous series is a family in an organic compound which follows a regular structural pattern, or in which each successive member differ by CH2. Let me come again. This place, you say this person and this person is from a family. They're from one family. So now homologous series says it is a family in an organic compound which follow a regular structural pattern, the same pattern, but in which successive member differ by CH2. Anyone that is coming after it must be different by CH2, in which successive member differ by CH2. Now, let's see it now. When you come to the homologous series, in homologous series we have the families. Look at the families. Number one, we have alkane, ANE. It's a family. We have alkene, ENE. It's a family. We have alkyne, YNE. It's a family. How many families are here now? 3. So we have 3 families here. Let's see if it is true. The homologous series is a family in an organic compound which follow regular structural pattern and in which successive member differ by CH2. Let's go by this. Now, understand that in this homologous series, they have what we call molecular formula. They have their formulas. And what are the formula? The formula of this alkane, ANE, so that you will not mistake it with alkene. This one is alkane. Why this one is alkene? Why this one is alkyne? Why? Start with this one. ENE, ANE, alkane, alkene, and alkyne. 3 family. So that is to say, homologous series as a father married 3 wives. Let's just put it that way. So 3 family. This is first family, this is second family, and this is third what? Family.